Quantum mechanics is one of the most fascinating and mysterious areas of science. It's the foundation of modern physics, governing the behavior of particles at the smallest scales imaginable. But there's more to it than meets the eye. In this video, we'll uncover 5 mind-blowing things you probably didn't know about quantum mechanics. Let's dive into the quantum world. Did you know that particles can exist in 2 places at the same time? This phenomenon is called quantum superposition. At the quantum level, particles like electrons don't have a single fixed location. Instead, they exist as a probability cloud, meaning they can be in multiple states or places until they're observed. A famous example is the double-slit experiment, where individual electrons behave like waves and pass through 2 slits simultaneously, creating an interference pattern. But here's the twist. When you place a detector to observe which slit the electron passes through, the pattern disappears and the electrons behave like particles. This challenges our classical understanding of reality, where objects are either here or there. It suggests that at the quantum level, reality is fundamentally probabilistic until we measure it. The second fact is quantum entanglement, which is one of the strangest and most counterintuitive phenomena in physics. When 2 particles become entangled, their properties become linked, even if they're separated by vast distances. If you measure the state of one particle, the state of the other instantly adjusts, no matter how far apart they are. For example, imagine 2 entangled electrons. If you measure one and find it spinning up, the other will immediately spin down, even if it's on the opposite side of the universe. This happens faster than the speed of light, something that deeply troubled Albert Einstein, who famously called it spooky action at a distance. Entanglement has been experimentally proven countless times and forms the basis of revolutionary technologies like quantum computing and quantum encryption. These systems exploit entanglement to perform calculations or transmit information in ways that are impossible with classical physics. In the classical world, an object hitting a wall can't pass through it. But at the quantum level, particles don't play by the same rules. But because of our third amazing phenomenon called quantum tunneling, particles can pass through barriers they shouldn't be able to cross. Here's how it works. Particles aren't solid objects in quantum mechanics. They're described by wave functions, which represent the probability of finding them in a given location. If there's even a tiny chance of the particle being on the other side of a barrier, it can tunnel through and appear there. This idea isn't just theoretical. It's the reason technologies like scanning tunneling microscopes can image surfaces at the atomic level. Quantum tunneling is also a key process in nuclear fusion, the reaction that powers the sun and could one day power the Earth. One of the most puzzling ideas in quantum mechanics is that the act of observation can change reality itself. At the quantum level, particles exist in a state of probabilities, described by their wave function. This means they don't have a definite position, momentum, or state until they're measured. This is known as the observer effect, and it's vividly demonstrated in the double-slit experiment. When particles like electrons are not observed, they behave like waves, creating an interference pattern. But when you observe them, they behave like particles, as if they know they're being watched. This has led to deep philosophical questions. Does reality only exist when we observe it? While quantum mechanics doesn't require consciousness to explain this, the idea that observation affects reality continues to fuel debates among scientists and philosophers alike. Quantum mechanics isn't just theoretical, it's the backbone of much of the technology you use every day. For example, semiconductors, which power computer chips in your smartphone and laptop, rely on quantum principles like tunneling. Lasers, which are used in everything from barcode scanners to medical surgeries, are a direct application of quantum mechanics. GPS systems, which require incredibly precise timing, depend on atomic clocks that work using quantum principles. And now, we're entering the era of quantum computing, which harnesses the power of superposition and entanglement to solve problems far beyond the reach of classical computers. These machines could revolutionize fields like cryptography, artificial intelligence, and even drug discovery. So, while quantum mechanics may seem abstract, it's shaping the future of technology and transforming the world around us. Quantum mechanics may seem mysterious and complex, but it's a fundamental part of our reality and our future. From particles existing in two places at once to revolutionary technologies, the quantum world continues to amaze and inspire. Which of these facts surprised you the most? Let me know in the comments below, and don't forget to like this video, subscribe to the channel, and hit the bell icon for more fascinating science content. Thanks for watching. See you in the next one.